Welcome. This video discusses scope and the lifespan of variables. So the basic problems we're trying to solve are that not every piece of information in a program should exist for the entire run of the program, and not every piece of information should be accessible from everywhere in the code. As programs get really large, it becomes too hard to reason about who's modifying which piece of information if every part of the code base can access any piece of information. So the rules for scope allow us to have temporary variables that come into existence and then go away when we're done with them. They allow us to reuse names, the same name for a variable in different places in the code base. And they establish some rules for who gets to access pieces of information and limit that to when the kind of a need-to-know basis. The basic rule for scope is that a variable exists in a block of code, and in general what that means is inside a pair of curly braces where it is defined, so this variable x here is declared inside this set of curly braces, so that is its scope. That is the place it makes sense to talk about x. Y is declared inside this set of curly braces, that most narrow set of curly braces. So what that means is y scope is just in these lines. It only makes sense to talk about y within that block. Once we leave that block, y goes out of existence, and if I try and work with y down here, it actually becomes an error. There is no more y. Y disappears the second we leave the scope it's defined for. Now, once a variable's been created, if we go into a more narrow scope, if we enter a new set of curly braces, the old variables stick around and we can continue working with them. So in this example, we start main, x is declared inside the scope of the main function, so it's going to exist all the way through here, which means we're free to modify it inside this if, and any changes we make will persist once we leave that scope. So scope defines the lifespan of a variable, but once a variable exists, we can go into a narrower scope, keep using the variables from the wider scope, in this case from the main function, and any changes we make within this block, this nested block, are going to persist once we leave it, as long as they're happening to variables that already existed. Now we can see this behavior if we switch over to Qt Creator and debug this chunk of code. So I have basically the same chunk of code, slightly different. I'm going to go ahead and fire up the debugger. And we come in, and the first thing I can see, I've got a breakpoint right here in line 8. And we've entered a scope where x is defined, but has not been given a value yet. So x, I can see x exists in this scope, but we haven't initialized it yet. If I go ahead and step over this line, then great, x has now been assigned the value of 1, and we've actually stepped down into this next line into y gets assigned 2. So in this scope, we now have a y to talk about. It has not been assigned the value 2 yet. Let's go ahead and run that line. I'm going to press F10. Great, y has been assigned. We're going to modify x. So x now has a value of 2 as well as y. I can print out what y is, really just to have something to do. And we come back out, y has disappeared. We can see over here in the list of local variables that there is no more y, but there is still x, and x now has that modified value of 2. So the debugger shows us what variables are currently in scope for whatever line we're currently on. Now I'm going to kill this for a second. I'm going to make a slight change, and this is kind of an evil change. Going to go ahead and rebuild the code. And you'll notice I've got multiple warnings on line 12. One, that I'm not using the variable x, but also this declaration of x shadows a previous local. So what does that mean? Well, let's go ahead and run the code in the debugger. and see what happens. So x is 1, start stepping. I get into this block, and now it shows me that there's actually two different things called x. Int x says, hey, I need a new variable x that's going to hold an integer, and we assign the value 1. We get into this scope and we say, hey, I need another variable x that is an integer. And so now within this scope, x means this new thing. And this new thing we're going to end up assigning the same value that y has. We're going to copy y into this new x. And so if I do something with x in here, it's talking about this new one, this one from the most recent narrowest scope. And then once we leave here, that x is going to go away, the one that we just changed to 2, and we're back to the original one. So now x goes back to meaning this thing that exists across the whole function. This is generally something you don't want to do. Shadowing a variable makes it really easy to lose track of which one you're talking about. Having two variables in the same function that are both called x is probably a really bad idea. If you ever see that warning about shadowing a variable, what you now know that it means that you've used the same name for different variables in a nested scope like that. So, other ideas. It's often the case that we need to modify our code to kind of work effectively with the scope of variables. So let's say I'm writing this code where I'm trying to calculate the total of an order, that's both the price of the order and the amount to ship it. So I do something like this. Double price is 5. That would be something I'm taking from the console, from some kind of input in a real program. But then I go do an if, and I'm going to figure out if the shipping should be $3 or $2. And then I want to use that shipping amount to calculate a total. Well, the problem is each of these shipping variables only exists within the curly braces it's inside. So we're going to create shipping and give it a value of 3, or we're going to create shipping, give a value of 2, and then either way we're going to forget about that totally. Way to make this code work is to hoist that variable outside, that shipping variable outside the if-else, or put everything into the scope where the shipping is. Well, this would be a bad solution. A bad solution duplicates our code so that we can work around the scope problem. We do something like this: if price is less than 10, then make shipping be 3, calculate the total, and print it out. Otherwise, make shipping be 2, calculate the total, print it out. We don't like having the same code in multiple places. A better way to deal with this problem would be something like this. Declare the variable shipping outside the if-else, because we need to use shipping. That's a concept that we're going to have to keep using in this wider scope of the function. So we just create the variable. Even if we don't have a good value for it, I can assign it the value 0, or I could default it to 2 or 3 and then change it if need be. Then do our logic for changing the variable. And then we can use it and know that we'll be working with whatever value got set inside the if-else. But we had to hoist the declaration of that variable outside the if-else so that it exists after we're done with the conditional. In general, there's kind of a balancing act. We want to avoid duplicating code and avoid repeating ourselves in lots of places, but we also want to minimize the scope of our variables. If you start off writing a program or start off reading a program, you don't want to be confronted with a giant list of every variable that's ever going to possibly exist in this program. Instead, what we want is to declare variables when they're needed. Occasionally, we declare them a little bit early because we're going to need that variable across multiple parts of the program. All right, so if I'm writing a program to read in information about an employee and calculate their paycheck, I'll declare some variables to store what type of employee, salaried or hourly. I'll read that in, and then I'm going to figure out if they're a salaried employee, I need to get their salary, so I'll declare that just in the if. If they're an hourly employee, I need their hours and pay rate, so I'll put that in the else if. But if they're a salaried, I don't need to know their hours. So there's no point in declaring that variable for the whole program. I'm just going to restrict that to where it's needed. And the point of this chunk of code is to calculate their pay. Either way, if they're a salaried employee or if they're an hourly employee, I'm going to try and calculate their pay. So great, what I'll do is I'll put that variable outside the if-else, and then in both the if and the else, and else is not fully displayed here, but both of those are going to set the pay variable. And then after the if-else is done, we can just print out the final pay. Right? So the pay variable has been hoisted out of the if-else because we need it across the whole length of the program. Other variables like hours and pay rate that really only apply temporarily to get that information and do some calculations in one particular situation, those we've left inside the more narrow scope of the if or the else if.